Government of India, Prime Minister has just gave a call for Digital India and Make in India. And in this India, we have been working for last many years. We have started this organization 30 years back with test and measurement product line, selling these equipment to a lot of industries, including telecommunication. A few years back, we started developing a product, micro BTS, for rural telephony, which is now well accepted world over, many operators, many countries, and in the final stages of testing at Telecom Engineering Center. One of the system is deployed successfully in BSNL network in Bihar and working absolutely fine for almost 1.5 years.
We have got a very good dedicated R&D team. The problems of getting the connectivity to the rural areas, especially in the hilly areas. So we are basically trying to develop a product which would be suitable to give mobile communication and connectivity in the rural areas. We have also got technology from abroad, and we have also taken the help of IIT Guwahati to develop appropriate technology for 3G and 4G BTS, which can work for the small rural communities, especially the communities which are in the mountainous region or in the island regions.
24 into 360 days, we are taking bath under EMF shower. Now, throughout the world, people are concerned regarding health hazards due to the electromagnetic field radiation. Now, whether it causes cancer or not, that's a debate. But who has prescribed certain, WHO has prescribed certain norms that the radiation level should be under that limit defined by the ICNIRP. Now, what we did, we have designed a setup, this electromagnetic field strength measurement setup. So, it is a triaxial antenna. It has got 3 dipoles inside it. It receives radiations from all corners in the frequency range of 30 MHz to 6 GHz. Now, there is a spectrum analyzer. So, the role of the spectrum analyzer is to analyze the signal received here. So, what it does, basically it's a frequency domain equipment. So, it displays the result power versus frequency. Now, the whole setup is being controlled by the software which we have designed in our R&D lab. So, from in that software, we calculate electric field strength, magnetic field strength and power density. We normally go to the sites and evaluate the strength of the electric field, whether it is within the norms defined by the DOT. If it is within the norms, then it is fine. If it crosses the norms, then we ask the operator to reduce the power or to increase the antenna height, like that, to ensure that everywhere the strength, the field strength is within the norms. That is our goal. So that's why I have designed this our setup.
We've been working in many projects, and one of the projects of micro BTS where we have rolled in IIT Guwahati for their 3G and 4G connectivity, because going forward the technology will definitely change to the next level. Otherwise, product have been deployed in many countries now already, and we're talking to countries like Bhutan, Malaysia, Indonesia, Benin, Nigeria, and Ghana. Many countries have been working on this product.
So this is our new lab. Here we are developing micro BTS. So to cater the need of the people residing in rural area, we have designed this setup. It consumes very less power, only 90 watt, and the whole system operates on -48 volt supply. Now, normally we use solar panels to trap the energy from sun. There is a battery bank. To charge the battery, we use a controller, charge controller. Now, from that battery, we supply this micro BTS, which normally we install it in remote areas. Now, it has got 2 TRX, one TX filter, duplexer, some front-end circuits like low noise amplifier, and these are all power supply circuits. This is the SBC. So the main software is being designed here. So here we develop the software. Now we download the software in this SBC. Here are the servers. Normally these servers exist in the core network of the operator. Now the link between this gateway and this pod is through satellite. So the motto is, if we are able to see the sky, we can communicate. As we know that a farmer also can afford a mobile phone, but due to the lack of signal, due to the lack of tower, they can't utilize those mobile phones. So this FlexiPod, this solution we can install anywhere, in any corner, in any villages of India, where local people can utilize their mobile phone.
Another initiative on our R&D side which we are doing is developing a low-cost machine for farmers where they can test the soil conditions. Soil, as you know, changes every few kilometers in this country, and that farmers doing the traditional way of cultivation, they put the same fertilizer year on year without knowing the condition of the soil changes so frequently. So I'm sure this is going to help them a lot, increase their productivity and the quality of their product.